Hello friends, this video on CET Neet crash course on motion in a plane chapter is brought to you by Pratibimba Learning by Reflection. This video will have solutions for MCQs of CET Neet questions. Subscribe our channel and also share this video for students who are preparing for their CET Neet examinations. Let us start with the solution. A vector sum of two forces is perpendicular to their vector differences. In that case, the forces, so we have four options and we have to choose the correct option from the given four. Let us look into the question, look back into the question. It says the vector sum of two forces. So we have to consider two forces as vectors. Let the vectors be, I'll write the solution. Let the vectors be vector A and B. Okay, so these two vectors, the sum of them can be written as what? Vector A plus vector B. Vector sum it is told, right? That is why I have written it as vector A plus vector B. It is perpendicular to. So how do you write the symbol for perpendicular? Let me write it like this. Sum of two vectors is perpendicular to their vector differences. I'll write it as vector A minus vector B. Sum of vectors is perpendicular to difference of those two vectors. So if two vectors are perpendicular to each other, what about the dot product of two vectors? I'll consider if two vectors are perpendicular to each other, perpendicular to each other, then their dot product is equal to 0. I'll write vector A plus vector B dot vector A minus vector B is equal to 0. I have taken the dot product of the two vectors to be 0. So on multiplication, what if I multiply this vector A to both the terms over here? I'll get vector A dot vector A minus vector A dot vector B plus vector B dot vector A minus vector B dot vector B is equal to 0. You know that vector A dot vector B is equal to vector B dot vector A. That is how plus vector A dot vector B and minus vector B dot vector A will get cancelled. What about vector A dot vector A? I can write it as A square. Similarly, vector B dot vector B can be written as B square, which is equal to 0. Or I can also write A square equal to B square. What we have seen is magnitude of vector A will be equal to magnitude of vector B. Their magnitudes are equal. I can write magnitude of vector A is equal to magnitude of vector B. Okay, so we have got the answer for this. Let us find the correct option from the answer that we have got. Are not equal to each other in magnitude. No, this cannot be the correct option. cannot be predicted, not actually, are equal to each other. Are equal to each other? No, vectors are not equal to each other. We have got magnitudes of vectors to be equal, right? Are equal to each other in magnitude. That is why we have option D as the correct option here. Let us look into the question. A particle moves along a circle of radius 20 by pi meter with the constant tangential acceleration. If the velocity of the particle is 80 meter per second at the end of the second revolution after the motion has begun, the tangential acceleration is. Here we have to find the value of acceleration that is being acting tangentially for an object that is moving in a circular path. Let us say the object is over here. The acceleration need to be acted tangentially at that point. I'll write it as 80. What is the radius of the circle? It is given. I'll write radius is 20 by pi meter. It is moving with constant tangential acceleration. Acceleration is constant. The velocity of the particle at the end of second revolution. Velocity will be our final velocity v. 20 meter per second. How many revolutions are completed? Number of revolutions here are 2. The tangential acceleration need to be calculated. Before that, let us now calculate the value of angular velocity. Since we know the value of velocity, angular velocity can be calculated. For any object that is moving in a circular path, it will have linear velocity as well as angular velocity. Angular velocity is the one that makes it to revolve in the circular path. Angular velocity can be calculated with the formula. We have v is equal to r into omega, right? Omega itself is the angular velocity. Omega is equal to v by r. What is v? It is 80. R is 20 by pi. Hence the value of omega here is 4 pi. Angular velocity is 4 pi. Since initially the object was at rest, right? Don't you think that the object will be at rest initially? Yes, it will be. Its initial velocity u will be 0. What about the initial angular velocity then? Omega naught. It will also be 0. Using the equations for rotational motion, using the equation of rotational motion, we have this. Rotational motion gives us omega square is equal to omega naught square plus 2 alpha theta. Omega square is how much? It is 4 pi, right? It is 4 pi the whole square. Omega naught square, however, it is 0 initially. What is 2 alpha theta? Alpha is nothing but our angular acceleration. Theta is angular displacement. Alpha is angular acceleration. Theta is angular displacement. Angular displacement. That means the value of theta for one full circle will be 2 pi. How many revolutions did it take? It has taken 2 revolutions, means it is theta is equal to n into 2 pi. 2 pi since it is for one revolution, which is 360 degree. I'll get theta is equal to 4 pi, right? 2 into 2 pi will be 4 pi. The value of alpha is what we have to calculate in order to find the value of AT, that is tangential acceleration. Theta is 4 pi. 8 pi into alpha, 4 pi the whole square. What is the value of alpha for us? It is 2 pi. Hence, we can now calculate tangential acceleration. Tangential acceleration is given by AT is equal to R into alpha. R is 20 by pi. Alpha is 2 pi. That is equal to 40 meter per second square. Which is the correct option among the 4 given options? It is, yes, option B. Option B is the right one. A stone is attached to one end of a string and is rotated in a vertical circle. If the string breaks at the position of maximum tension, it will break at. Let us mark this as the center of the circle, and the stone is being rotated in a tangential, rotated in a vertical circle. So if the stone needs to be rotated, let us say at one point it can be even here, right? So let us say the stone is being rotated and it reached here. It makes an angle of theta, which is angular displacement theta. What about the weight of the stone? It will be acting vertically downwards, mg, right? There is the force that is acting vertically downwards due to the gravitational force of attraction. Weight of an object is in this direction. The weight mg is resolved into two components. One is vertical component, the other one is horizontal component. Vertical component is written with mg sin theta. Horizontal component is written as mg cos theta. Why? Because this is our angle theta. Now, let us assume the initial position of the string was over here. Initially, the string was over here. I mean, the stone was over here. Along with the string, the stone is here. And what about the value of theta? It will be 0, right? Later, when it came to this position, the value of theta went on increasing. Okay, so here there is one more force that is being acted towards the center of the circle. What do we call that force? It is nothing but the tension. Tension is acting along the string towards the center. What about the net force in such case? The tension, I can also write it over here, right? Since the object is being rotated here, I'll write net force that is being acted as equal to T minus, what about the direction of mg cos theta? It is here. I'll write mg cos theta. This net force will be equal to the centripetal force. The force required for the stone to revolve in a circular path is provided by the centripetal force. I can write T minus mg cos theta as equal to mv square by r. But what if the stone is at the lowest position? This is the lowest position. I'll write T lowest. I'll shift this mg cos theta to the other side and let me determine the value of T. Mg cos theta. What are the different values of theta I can have here? At the lowest position, the value of theta is equal to 0 degree. What is cos 0 degree? It is 1, right? So this tension will be the maximum when this mg cos theta is maximum. Mg cos theta can be maximum only when theta is equal to 0 degree. Theta is equal to 0 degree is when the stone is at the lowest position. At the lowest position, the tension will be the maximum, right? The string can break only at the maximum value of tension. Clearly, tension is maximum at the lowest position. What are the other values of theta you can have? If the stone reaches here at the point D, the value of theta is equal to 90 degree at D, right? So I have written this for the stone being at B. At D, what happens? Theta is equal to 90 degree, cos 90 degree is equal to 0. In such case, tension can be lesser compared to the stone being over here. When the stone reaches here, it gets the less tension. The force of attraction towards the center reduces. What about at A? The value of theta is 180 degree. Angular displacement is 180 degree. I can say cos 180 degree is minus 1. Again, at A, it still reduces, tension decreases, right? Similarly, at C, what will be the value of theta? It is 270 degree. At 270 degree also, cos 270 degree is again equal to 0. That is why at three different points D, A and C, the tension is minimum. The string can break only at the maximum value of it. The string breaks at the position of maximum tension. We have found where can be the tension maximum. Tension is maximum at the point that is B. Clearly, tension at the lowest position. Tension at the lowest position, that is at the point B, is being maximum, right? Hence, I can say here the option B is the correct one. We'll move to the next question. Question 4. Two particles are projected with same initial velocities at an angle 30 degree and 60 degree with the horizontal. Then there are four given options to be chosen. There are four given options to be. Here we will consider the particle to be thrown at an angle 30 degree. This is the velocity, or it is the direction of projection. It will cover a horizontal distance, say r, right? This is the height, maximum height, and it takes total time t. And there is another particle which is thrown at an angle of 60 degree. It reaches certain height and it will come to the ground level, and this is the height. They are asking what will be the height, what about the time, that is time of flight, as well as the range for these two objects, these two particles. We have the formula for height as u square sine square theta by 2g, t is equal to 2u sine theta by g, r is equal to u square sine 2 theta by g, right? So let us find height, time of flight and range in each case for each of the particles. I'll write particle 1 as whose height is taken to be h1. Particle 2's height, of course, it will be different. It is written as h2. Let me find h1 and see what happens. U square sine square 30 degree divided by 2g, or I'll write u square into 1 by 2 whole square. Sine 30 is 1 by 2, the whole square, whole divided by 2g. That can also be written as equal to, the answer is u square by 2g. What about the height h2? Of course they are not going to be equal. What if I substitute sine 30 degree with 60 degree? I'll replace it with 60 degree, and sine 60 degree is root 3 by 2. However, h1 will not be equal to h2. If you try to find the value of r1, which will not be equal to r2, because sine of an angle theta changes. If that change, there is no point being equal. What about time of flight t1? They are also not equal, correct? That is why, which is the correct option among 4 given options? Let us look into the first one. Their heights will be equal? No, heights are not equal. Their ranges will be equal? No, ranges are not equal. Their time of flights will be equal? No, their ranges will be different. Yes, this is the correct option. Moving on to fifth question. A person swims in a river aiming to reach exactly opposite point on the bank of a river. His speed of swimming is 0.5 meter per second at an angle 20 degree with the direction of flow of water. The speed of water in stream is. Here we need to draw the relevant diagram. So let us say this is the stream of water and the water is flowing in this direction. Let me write v u dash as the velocity of flow of water. Okay, water is flowing in this particular direction. What if the person wants to swim to the other side? The person, let us say he is over here. He wants to move to swim to other, exactly the opposite side, opposite point on the bank of river. He wants to reach here. But what if he swims in this particular direction, only in this direction if he swims? There is not possible, it is not possible for him to reach this point, right? From A he wants to move to B. If he swim in this direction, it will not be possible for him to reach B. Where he will reach? Because the flow of water is this way, there is a chance that he might reach this point, right? He is not going to reach there. He doesn't want to reach there. So what does he do? He swims in this particular direction. Okay, he swims by making an angle of 120 degree with the direction of flow of water. He swims in this direction so that he can reach here. He swims towards C so that he can reach B, because the water is also flowing. Along with the flow of water, he is going to reach B, but he is aiming at C by making an angle of 120 degree. Let us now write the speed in which he is swimming, that is his velocity u. His speed of swimming is u, that is 0.5 meter per second. What about the angle that he need to make with the direction in which he has to actually swim? He should make an angle of 30 degree. Why? Because this angle is 90 degree. 90 minus 120 is 30 degree, right? So what is the speed in which the river is flowing, person is swimming with the velocity of u, river is flowing with the velocity of u dash? This is what we have to find. We have a small triangle here, right? I'll shade the triangle that I have to take. This is the triangle I'm talking about. In triangle ABC, let us find the value of speed of river. Speed of river is nothing but u dash. It is over here. The river is flowing in this direction. What is sine theta? Sine of an angle theta. Sine of an angle theta is opposite side by adjacent side. What is the opposite side? U dash. Adjacent side is u. U dash is equal to u sine theta. U is equal to how much? We have written it to be 0.5. Sine theta is sine 30 degree. Right? What is sine 30? 1 by 2. U dash is equal to 0.25 meter per second. Hence, we find the velocity or the speed of water in stream is 0.25, which is option C, 0.25 meter per second.